All right, today we have our second transformation, which is going to be a translation. Just give me an idea, guys. Let me know if this microphone sounds a little bit better than the one I've been using. I'm trying to use the one from my headphones. So let me know if it's helpful for you guys. All right, so the first thing we need to know about a translation is we call it a slide or a glide. We do need to know that it is a rigid motion, which we spoke about yesterday. And we also need to know that it is called a direct isometry. So that's something that we're going to talk about tomorrow. The way that translation is written is its notation is a capital T with two numbers in the subscript. Now, our general rule for translation is to take a point XY with these two numbers under here, A and B, and all we're going to do for a translation is we're just going to add those numbers to X and Y respectively. So the new point is going to be X plus whatever letter A is, and Y plus whatever B is, and that's going to give us our new point. All right, so for our first example, what we're going to do is we're going to plot point A, which is 3, 4, and make sure that we label it. What I also like to do is I like to draw my point over here on the side, 3, 4, with my translation of -5, 3. It says in the question that it's going to turn into point A prime, so I'm going to put my A prime right here. The math that I have to do, if we refer to the formula above, is I'm going to take 3, and what we're going to do is add this -5 to 3, which is going to give us -2. And then we are going to take this 3, and we are going to add it to the 4. So we're going to have 4 plus 3, and that's going to give us 7. Once we have our final point, or our final set of coordinates, we can graph it, which would be -2, +7. And this would be the point A prime. Now, basically what a translation does in a slide, if we look at the translation notation itself as capital T with a -5, 3, the first number, -5, tells us how far either to the left or the right we're going to move, and the second number, 3, tells us how far up or down we're going to move. So if you look at point A to A prime, we move to the left 5 spaces, and we actually move up 3 spaces. So you could do it on the graph if you wanted to. The best way to do it is to do the addition and subtraction like this. And if you have a triangle, square, or rectangle, you're going to want to do it the exact same way. You would just be doing it to multiple points, not just point A. All right, the other way this question can be asked is they can give you both your starting point P and your ending point P prime. And they can actually ask you to figure out what the translation is that takes you from P to P prime. Now, this is much easier if you have a graph, because then you can count the spaces. So we can always put this question on a graph, but I do like to show it algebraically just so we understand the formula and what's going on. So I'll list out my points P and P prime, and what I'll try to think of is how would I get from a -2 to a +4, because what I'm looking for is a translation of two numbers, A and B. So the A number is going to tell me how I got from my -2 to my +4. You can use your calculator to figure this out. I can do it in my head, and I would count as +6. So that's going to go in for my A. The next thing that I would look for is how do I get from a 3 to an 8? So the only way for me to get there would be to add 5 to it. So my final answer is going to be this translation with a +6, +5, which also tells us that we move to the right 6 units and up 5 units if it was asking. All right, we're going to be able to do this tomorrow, and what we'll be practicing tomorrow is how to perform translation on figures. So you'll have to do this for 3 different points or 4 different points, depending on what shape we're working with.